Today we're going to be working on Leetcode question number 113, path sum 2. Uh, we in the previous one we did a very similar question. So we have been given a root of a binary tree and an integer target sum, and this time we're going to be returning root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as the list of the node values, not node references. So a root to leaf path is a path starting from the root and ending at any leaf node. A leaf is a node with no children. So basically we're going to be returning the, what did he say, the list of node values, not the node references. Yeah, so we're going to be basically putting, once we find the path, we're going to putting them in an array, just the values of the every node in an array, and we'll be returning those arrays. We're going to be doing it recursively. Yeah, so basically it's going to be a DFS, and initially we're going to be doing, like, we will have a result which is an empty array. Then we're going to be calling our DFS helper function with the root value, uh, the the current sum, the list, which is going to be an empty array again, and the result where we're going to be putting our once the base condition does match, we're going to be putting the list into the result, and in the end we're going to be returning result. So our DFS looks like the DFS takes the root, it takes sum, and it takes the list and the result. So if the root exists, right, if the root is there, then we're going to process it. The way we're going to process it is like the base condition is going to be that if that the root, if not root, right, if not root dot left, if we don't have any left child, and not root dot right, and don't have any right child, meaning we are on the leaf, and definitely we have the value, the root cannot be null because we already checked that, and our current sum is exactly equal to root dot value. If that is the case, we're gonna say that the ls append this value, the current root value, and then we're gonna be appending ls to our result dot append ls. Okay, if that is not the case, we're gonna recursively call this DFS. So one time we're gonna be going to the left side, that the sum is we're gonna subtract the current value from it, and then we're gonna say that in ls we're gonna be adding a root dot value, and then the result. Similarly, we're gonna do the same thing for the right child, sum minus root dot value, ls plus root dot value, and then the result. Okay, let's see. Unsupported operands. What? What? Built-in function or method and DFS. So we are calling the let's see, we are calling the root, the DFS with root dot left. The next one is the sum minus root dot value, and then we have we added the value to the ls, right? And then what is the error? Complaining unsupported operand type. We do have the root dot left, right? We have a left, right, and a value. That is interesting. Unsupported operand types for built-in function or method and int. We are calling DFS. Yes, DFS. Then we are calling root dot left. Then the sum minus the value and the LSI. So the number of arguments are right. Oops. Of course, there's a typo here. Unsupported operand types. Line number 20 has error. This is not complaining about temp value is equal to sum minus root dot value and then temp value. Sum is not a keyword, is it? No. If we have the root, if not root dot left and not root dot right, and sum is equal to root dot value, interesting. Feel like he is not liking this current sum. Oh, it is a target sum. Did I send the target sum to it? No. Okay. Okay. We are sending a target sum. And this time it did pass. So basically this Python, so sum I think is a keyword now. Okay. But if I do sum like this and sum like this, sum like this. So yeah, sum is not a problem here. It's that I was initially sending a value which doesn't even exist. So that's what it was complaining about. Okay, and it passed all the test cases.